Have you ever wondered why magnets attract or repel each other? It's all due to an invisible force that exists between them. A force described by a fundamental physics principle known as Coulomb's Law. This law, named after the French physicist Charles-Augustin de Coulomb, who discovered it in the 18th century, is a cornerstone of electromagnetism. It provides us with the rules to understand how charged objects interact with each other. Coulomb's law describes the force between two charged objects. It states that this force is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. But what does this mean in simple terms? Well, it's like a game of tug-of-war. The stronger the individual players and the closer they are to each other, the greater the force of the game. Today, you will get a simple understanding of this fundamental law. Dive in and let's demystify Coulomb's law together. To grasp Coulomb's law, you need to understand two key terms: force and charge. Let's start with force. Picture a push or a pull on an object. That's essentially what force is. It's the interaction that, when unopposed, changes the motion of an object. Whether you're pushing a door open or pulling a cart, you're exerting force. Now, let's talk about charge. Not the kind you get on your credit card, but the kind that's a fundamental property of matter. It's what causes an object to experience a force when placed in an electromagnetic field. Charges come in two types, positive and negative. And here's a fun fact. Similar charges repel each other, just like two north poles of a magnet, while opposite charges attract, like a north and a south pole. Now that we have the basics cleared up, we can delve deeper into Coulomb's law. So, what exactly is Coulomb's law? This fundamental law in the realm of physics is all about charges and how they interact. Let's take it step by step, shall we? Coulomb's law is named after the French physicist Charles-Augustin de Coulomb, who formulated it back in the 18th century. It's a key principle that helps us understand how electric charges work. The law states that the force between two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Sounds a bit complicated, right? But don't worry, we're going to break it down. Think of it like this. You have two charges, let's call them Q1 and Q2. The force between these two charges will depend on two things: the value of these charges and the distance between them. Let's look at the formula. F equals sine kq2r squared. Here, F represents the force between the charges. On the right side of the equation, we have K, which is Coulomb's constant. This is a fixed value that helps us calculate the force. Next, we have Q1 asterisk Q2, which is the product of the magnitudes of the two charges. This means that the greater the charges, the greater the force between them. The denominator, r squared, represents the square of the distance between the two charges. This is where the inverse part of the law comes in. As the distance between the charges increases, the force decreases, and vice versa. It's a bit like social distancing for charges. The further apart they are, the less they interact. So to sum it up, Coulomb's law describes how charges interact with each other. The force between them depends on their individual magnitudes and the distance between them. In simpler words, the force between two charges reduces as they move apart and increases as they get closer, or as the magnitude of their charges increases. So Coulomb's law is an essential tool to understand the invisible dance of charges happening around and within us every moment. So, in a nutshell, what did we learn today? We delved into the fascinating world of physics and explored a fundamental concept: Coulomb's law. We started by understanding the basic definition of force and charge. Force, as we discussed, is a push or pull on an object resulting from the object's interaction with another object. Charge, on the other hand, is a property of matter that gives rise to electric forces and interactions. We then explored Coulomb's law, a cornerstone in the field of electromagnetism. This law tells us that the force between two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. The law is a key player in many natural phenomena we witness every day. Remember, understanding Coulomb's law doesn't just make you a physics whiz, but also helps you comprehend the world around you better. Next time you see magnets attracting or repelling, remember it's all thanks to Coulomb's law. Stay curious, keep learning.